Nothing exciting going to be going on. Just some help with some of the problems. All right. So equation review. You're like, shoot, why are we going back to Algebra 1? What's up with this? Basically, it's just to make sure we're not making silly mistakes as we get flying along here. Like, it's very simple to get into a problem like this where you look at the 15 and kind of want to go straight across. Doesn't quite work as well that way. Anybody want to share? Because I can think of a couple different ways I could tackle this to solve it. What's one way I could go after this?
Multiply both sides by 5.
I'm with you, okay? So if I decided I want to multiply both sides by 5, multiplying on this side of 5 would cancel the 5 out. And then I multiply the 15 by 5. And this is just a personal preference. I'm not going to jump up and down and scream if you do it. Here, if you divide and it doesn't go in evenly, okay? Typically, I'm going to tell you to leave it in improper fraction form. If you want to put it into a mixed, if you want to put it into a decimal, I don't care. But my reason behind that is when you get to standardized testing, most of the time they're going to have answers if they don't come out nice in improper fraction form. I just want to get you used to the visualization on that. But again, if you put 37.5, it's still the right answer. It's just a different way of doing it. Now, the other way you could decide to tackle a problem like this if you wanted to is you always could take the 15, turn it into a fraction by putting it over 1, and cross multiply. 2m times 1, 5 times 15, and I get to the same answer. So a lot of times it's going to come down to personal preference for you on how you want to do things, because I won't tell you you have to do it this particular way or that particular way. So just something to be aware of. 3, again, that's pretty easily set up like most of these are going to be. Just make sure that when you're cross multiplying we don't get sloppy with our math. It's about the worst thing that could happen to us on this. Now, some of you may even, when you go ahead and divide by your 15 in your set, you may look at this and decide, well, you know, couldn't I, if I really wanted to, could I start reducing these fractions before I ever start? Make this like 1 and 9 since 5 goes into 45. You certainly could. But again, it's all what you're comfortable with. If you're comfortable dealing with those numbers, I'd just keep going that route. This one I'm going to stay away from for a moment because I want to make sure we hit a little of everything here. 7, let me come up to. Because this is something that tends to get people. People get so excited about getting rid of the fractions, and they want to multiply through right away. And here's what typically happens in the case like this. If I were to multiply through by 5 right away on this one, people typically will multiply this by 5 and cancel. They'll multiply the 9 by 5, and that's the right thing to do. But then they forget about the 3 and they get to the wrong answer. Personal preference here, I want to isolate my fraction before I multiply anything. So I'm going to minus the 3 out of there first. So I'm not going to be the person making that mistake. Then I'll go back and get rid of the fraction. I'll multiply both sides by 5. So I only have the numerator remaining on the left. 6 times 5 is 30. And then I can just go about my business. And yes, at the beginning, at least until I get to know all of you better, I'm going to want to see something work-wise. Even if you sit there and go, I can just play guess and check and get to the number. I still want to see what's going on. So I don't mean as much that I have to show minus 3 times 5, but at least let me see so if I'm looking at something I can figure out, you know, what your thought process is going to be. Okay. I'm just looking through, trying to make sure that we're not running into any other fun things here. That's one other thing. Whenever we're going through these, if there's a specific one, I get whipping along and you're like, wait, can we go back and look at, just holler at me. We'll go absolutely do that. 5 even. Here, options. What's one way I could deal with number 5 to start with? Because again, I'm thinking of 2 possibilities here.
Multiply by 5 on both sides.
Okay, so I could multiply by 5 and then divide later. Anybody got any other ways they'd go after it?
You could change the fraction into maybe a decimal and then multiply the decimal by 16.
I can. And now the one thing I can get myself into trouble with on decimals occasionally is if it's not one that comes out clean, like 4/5 comes out clean, it's 0.8, I can do that. But if I get into one like 6/7, which would come out like 0.8333333, if I round it and then I go back through the divide, my answer is going to be off somewhat. So I want to be a little bit careful with that. So here on 5, I absolutely could multiply both sides by 5 first if I wanted to. Get to 4x equals 80. And then divide by 4. And again, I'm going a little overboard on my work showing. Or, if you wanted to, you also would have the option of just multiplying by the reciprocal. So if I have 4/5 x equals 16, I could just multiply both sides by 5/4. Take care of all that at once. And then at that point, the only thing that I'm going to have to be careful of, if I start looking at 16 times 5/4, is reminding myself the 16 is like in the numerator. If I physically have to put the over 1, I can. But then it'd be 80 over 4, which again gets me back to 20. Both get me to the right answer. Both perfectly acceptable. It's just whichever way you feel more comfortable with. Okay? And that'll work any time that you run into something with a fraction. But like we mentioned up in the top portion, the one thing I really do want to be careful of is when I get into something like 9. Again, don't get so excited about getting rid of the fraction that we do something to forget about this. So always isolate the fraction first. Excuse me. So I'll minus the 7 over. And then again, we get into the two options like we did over in number 5. You can either multiply by 9 and then divide by 7, or you can do it in one big swoop. I don't care. I'm going to go ahead and do the reciprocal this time. But if those of you like doing it the other way, you go ahead and do it, and we'll see if we get the same answer. Because here I can take care of everything at once. Now if I look at this, I'm like, I'm not doing that in my head. That's okay. Here comes the handy-dandy online calculator that we spoke of a little bit yesterday that you can get on the website. And then I would just do 63 times 9. Divide that by 7. Let's see. It comes out nice. So again, just give yourself some patience on that, and that should work out all right. The one last one on this side I want to take a look at is right below there, 13. Same type of situation. Isolate the fraction first, get the 4 out of there. And then here, I want to get rid of the fraction, so I'll multiply both sides by 4, which will leave me with the numerator. And the thing that tends to come into play here, where people can get a little bit careless, is they'll subtract the 17 over, and that'll be all fine and good, but then they want to quit. It's like, not quite, because that's a negative x, so we just have to switch a sign. And we're okay there, and we're ready to go. So it can be a little bit of a tedious process. But as long as you isolate your variable first, it shouldn't be anything that turns out too bad as far as the fractional part goes. Okay. Are there any other odds on this side that I skipped by because I thought they were kind of similar that you really want to see? Because otherwise I'm going to take a quick flip over here, get us a couple more, and then we might get to a little bit of the 1, 3. Okay, well, let's flip over. We'll get the calculator out of the way here. Okay, proportions, we're just cross multiplying. Keep it simple. 8 times 2y, okay, 16y. 11 times 3 is 33. Divide by the 16, and this again is just me. Leave answers as fractions, please, if needed, because this is the way I'll have them up when we're going over them in class. I won't have like 2.0875 up there. So if you have the decimals, you may have to look and say, okay, is that the same thing? Yeah, I'm not sure. The only other thing on this side that really concerns me, even though I'm going to hit one of the starred ones here in a minute, is when I go to cross multiply. Anytime you see a binomial term, you see a plus or a minus, I want you to immediately start looking for those and put parentheses around them. And here's why. When you cross multiply with these, that 3 that you're cross multiplying goes to the y and the minus 8. And a lot of times if people don't put the parentheses, they totally forget, and I see like 3y minus 8. I'm like, oh. So here, that 3 distributes and gives me 3y minus 24. 21 times 1 is 21. Now I can do it just like I normally would do any problem. Add my 24, because we need to isolate my y term, and divide by 3. And that's going to be the same on any of these. The only other thing I tell people to be careful of is if it's a whole number like it was here, I usually will put the 1 over there just so I can look at it like I would a normal cross multiply and not get mixed up with it. 5, same thing. I got my parentheses, so I'm not going to get sucked into that. And then I can go ahead and solve this. And again, it's personal preference. I like to keep my x's positive, so I'm going to move things to the right side. Move these back over. And it's going to be kind of a yucky fraction. Whoops, whoops, whoops. Harty, harty, harty. Things I got to be careful of. And that's basically all you're going to be looking at on the proportion side of things. If you see a binomial, put parentheses around it. Otherwise, cross multiply and solve the equation that's left. So again, on this particular sheet, only the evens are the ones that you need to be working with. Okay, otherwise you're just going to be playing around with the others if you happen to need them. But I think you've got good examples on those. Now, as far as the other sheet goes, we're just going to get a little bit of a start on this one. For today, I'm just going to hit on the stuff that I think is going to cause you the most immediate trouble. And then we'll go back and hit some of the other stuff tomorrow. The proportions we won't have to do, but the fractions, this gets a little nasty sometimes. So we're going to bump up a little bit here. So, for instance, on number 5, we're wanting to multiply the entire equation by the LCD. Not like the LCD TV that you look at, but otherwise known as the least common denominator. So for 6 and 12, what would my LCD be? 12. Because the way I think about it is, what would the smallest number be that both 6 and 12 would divide into? Well, 12 would be. If I started counting by 6s and 12s, the first number that I would see in both lists is 12. That's how I determine this. But the thing to remember is, when I'm using this to take care of the problem, even parts that aren't fractions need to be multiplied through by 12. So I have 12x. And then here, instead of trying to get complex and make everything a common denominator, just keep it simple. Multiply by the numerator, divide by the denominator. 12 times 5 is 60, divided by 6 is 10. 12 times 2 is 24, divided by 12 is 2. Now it looks a whole lot easier to work with. And again, I won't fight you if you want to find a common denominator and keep the fractions. I just honestly think this is going to go faster for you and make life easier. Same idea on number 6, just more numbers to deal with. So 2, 4, and 5 are my unique denominators. So if I were to count by 2 4s and 5s, first number we're going to have in common, 20. Okay? Now some of you may have been taught before, well, can I just multiply the unique numbers together and use that? Yes, you're just going to end up with bigger numbers. You'll still end up with the same answer at the end. So if somebody would have multiplied 5 and 2 and 4 and gotten 40 and multiplied through by that, you'll get the same answer at the end. It's just going to be a little bit trickier. So 20 times 3 is 60. Divided by 4 is 15. 20 times 3 is 60. Divided by 5 is 12. Let's see, 100 divided by 2 is 50. 20 times 1 is 20. Divided by 4 is 5. And then I just knock this out. But again, reminder, x's on different sides of the equals can't just combine like terms. Got to subtract. So we'll subtract the 15 over. Minus the 5 because I need to isolate my variable term. And then again, looks like we're getting a nasty fraction. Don't care. Just going to leave it that way. Okay. So now here's my 2 cents worth on this. I absolutely for sure am telling you the first sheet that we looked at here with our equation and proportion review, those evens should easily be knocked out, ready to go when you walk in the door tomorrow. Okay. I would say for most of you, what's going on here on the 1-3 sheet you're going to be okay on, unless you are running into some issues with the story problems on the back, which we're going to take a look at the very start of class tomorrow. If you get a chance to do some of the simpler problems in here, which are just the equations and the proportions, go ahead and get those done. We'll finish these up, and then we're just going to kind of stay in this section tomorrow and do some more story problem type things. So if you could get that taken care of, that'd be terrific. Do remember to bring your books back tomorrow because we are going to be using them. And yes, sir.
You want to do all this side?
I